Find angle A, angle B, angle C, and angle D in the following diagram. So angle A is going to be 90 degrees. So angle A, because this is an angle in a semicircle. So we see we have a circle, and we have a diameter cutting through the circle, cutting through the center of the circle. And we have a triangle formed from the diameter and two other lines, and that automatically makes a right angle. So no matter where this point would be on our circle, it would form a right angle. And likewise over here, C will also be a right angle, so it'll be 90 degrees. So we have 90 degrees and 90 degrees. So angle A is 90 degrees because it's an angle in a semicircle, and angle C is 90 degrees because it's also an angle in a semicircle. Okay, angle B. Well, if we know that angle A is 90 degrees, and we know that this angle is 35 degrees, and together with B they form a triangle, then to find B, we're going to say 180 minus 90 minus 35 will give us 55 degrees. And then to find D, angle D, this is this one here, well, we know that this is an isosceles triangle because this little line and this little line represent equal width or equal length. So this length is the same as this length. So this has to be an isosceles triangle. And we know that in an isosceles triangle, the angles at the end of the lines that are the same have the same angle as well. So this angle must be equal to this angle. And we know that this is 90. So if we take the 90 away from 180, we're obviously left with 90. And half of that is going to give us D, because this is the exact same. These two angles here are the same. So 180 take away 90 is 90. And 90 divided by 2 is 45. So angle D is 45 degrees. And that angle there that we were not asked for would also be 45 degrees. We should also note that in a cyclic quadrilateral, which is what this is, if we put the two triangles together, it forms a quadrilateral that's inside a circle. So it's a cyclic quadrilateral. And in a cyclic quadrilateral, opposite sides add up to 180 degrees. So 90 and 90 gives 180, and 35 and 45 and 45 and 55 will also give us 180 degrees. So just to recap, angle A is 90 degrees because we have a diameter and a triangle. So that has to be a right angle, 90 degrees. Or you could just say that a semicircle forms a right angle at the edge. And the same goes down for here. So angle C is 90 degrees, angle A is 90 degrees. Then we have a triangle, and 180, take away 90, take away 35, left us with 55. And down here we have an isosceles triangle. We know it's isosceles because these two lines mean equal length. So 180 take away 90 divided by 2 will leave us with 45. And 45 on the other side as well, but we weren't actually asked for that angle there. So we want to find angle OCA and angle OCB in the following diagram. So let's start with angle OCA. So angle OCA, so this angle here. So angle OCA, this is what we're trying to find. Well, this is actually an isosceles triangle because this is the center of the circle. So this is a radius, and this is a radius, and this is also a radius. So these lengths are all the same. So this is an isosceles triangle because this length is the same as this length. And also, this length is the same, but we're not interested in this for the moment. So if we're trying to find angle OCA, which is this angle here, what we have to do is take 64 away from 180 and divide it by 2, because this angle is going to be the same as this angle, and the three angles together will add up to 180 degrees. So triangle AOC, so AOC, is an isosceles triangle. So the length of AO is equal to the length of CO. because they are two radii. So therefore, angle OAC, so this angle here, and angle OCA, so this angle here, are equal. So therefore, angle OCA, this one that we're looking for here, is going to be 180 minus 64 divided by 2. So 180 minus 64 is 116, and 116 divided by 2 is 58 degrees. And we have 58 degrees, and this angle is also 58 degrees, but we weren't actually asked for that angle. So now we're going to find angle OBC. Okay, so now we want to find the angle OBC. So it's OBC, so this angle here. Okay, so we're trying to find this angle, and as I said before, we know that this length is equal to this length, which is equal to this length, because they are all radii. So they're all equal. So we can figure out what this angle is, because this is a straight line. So if we say 180 take away 64, it will leave us with this angle here. And then if we divide that answer by 2, we'll end up getting this angle and this angle as well, because these two angles are the same, because it's an isosceles triangle. So triangle COB is an isosceles triangle. So COB is an isosceles triangle, because the length of OC is equal to the length of OB. They are both radii. So 180 take away 64 is 116 degrees. So this is a straight line. So 180 take away 64 leaves us with 116 degrees. So angle BOC is 116 degrees. So BOC, 116 degrees. So then 180 minus 116 divided by 2 will leave us with our angle. So 180 minus 116 is 64. So these two angles combined together are 64 degrees, and 64 divided by 2 is 32. So the angle we're looking for is 32 degrees, as is the other angle over there. Alternatively, it could have helped us to know that this angle here is 90 degrees, because we have a diameter, which means we have a semicircle, and the angle formed at the edge is always going to be 90 degrees. So this angle and this angle combined will be 90 degrees. So we could have used that to help us get 32 as well, by taking away the angle that we had there, which was 58 degrees. Taking that away from 90 would have left us with 32 degrees, and that would also be 32 degrees. So there's usually going to be a few ways that you can complete these questions.